All right, let's do this. So these kind of get a little bit more increasingly difficult as we go here, okay? So remember, we're going to find our parent chain, that longest continuous set of carbons. In this case, we have these 6 carbons here. So what's my parent chain? A hexane. All right, we need to find our substituents. In this case, this 2-carbon group right here. And 2 carbons would be an ethyl group. And then to put the name together, we got to figure out where that ethyl group is. So we're going to number our parent chain in both directions here. We want to put our substituent on the lowest possible number, so that's why we're going to pick the red. So this would be 3 ethyl hexane. Right? No spaces, all run together. All right? So we get to this one here. When we're finding our parent chain, remember we need the longest continuous set of carbons. So this would be 1, 2, 3, 4. But if I started counting down, it would be 1, 2, 3, 4, 5. So this is my parent chain, the pentane. All right, and in this case, it wouldn't matter which way you were to number it here. My 1-carbon methyl group will be on carbon 3. So this would be 3-methyl pentane. All right, so now this one's all big and ugly. We got to find our longest continuous set of carbons here. The longest chain that we can find is these 4, 5, 6, 7 carbons. So my parent chain here is a heptane. Move this monstrosity out of the way. Okay, going through and identifying all my substituents. Here's a methyl group. Here's a methyl group. And these ones are bigger. Here's an ethyl group and a second ethyl group. So I'm going to go in and number my parent chain. 1, 2, 3, 4, 5, 6, 7. If I go the other way, 1, 2, 3, 4, 5, 6, 7. So now we got a bunch going on. So let's make a list of what it would be in each numbering scheme. The blue numbering scheme, I have 2 ethyl groups on carbon 3, right? So 3, 3, 5, 6. And if I go the other way, it would be 2, 3, 5, 5. Looking at just that first number there, I can see that I'm going to go with the red numbering scheme. That's going to get the lowest number in my name. Okay, but I have multiple methyl and ethyl, so how do we indicate that in our name? That prefix di, right? And now I got 2. I got a methyl and an ethyl. So remember, when we assemble our name here, we're going to put them in alphabetical order. So 5, 5, diethyl. 2, 3, dimethyl. Heptane. All right, so 5, 5, diethyl. 2, 3, dimethyl, heptane. All right, and then my last one, my parent chain is this set of 3, 4, 5, 6, 7, 8, 9 carbons. What is 9 carbons? A nonane. All right, we got again our methyl group and our ethyl group. And then what do we call it if it's 3 carbons long? Propyl group. So here's an ethyl. Here's a methyl. if we put in our numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. In our blue, it would be 4, 5, 6. If I go the other direction, 1, 2, 3, 4, 5, 6, 7, 8, 9. It would also be 4, 5, 6. So we got a tie. Now, in the case of a tie, and only in the case of a tie, how do we break our tie? The alphabetical order, right? So we're going to have to look and make sure that whatever comes first in the alphabet gets the lower number. So then would it be red or blue? Red. The red, right? The propyl's always going to be on carbon 5. So I'm really looking at my methyl versus my ethyl. E comes before M. So I'm going to put my ethyl group on the lower number. All right, putting it all together, we're still going to put the name together in alphabetical order, right? So 4-ethyl, LMNOP, 6-methyl, 5-propyl, nonane. Okay, so this alphabetical order business, it pops up in two different places. First of all, we always put our name together in alphabetical order. When we assemble our name, our substituents go in alphabetical order, always, right? The other place that it pops up is if, and only if you have a tie with your numbering scheme, you use that alphabetical order to break the tie, okay? It's kind of easy to conflate those two things. So again, we see this alphabetical order in two different places. All right, so we got one fairly quick topic to wrap up this chapter, and it's a lot of fun, and I mean that very sarcastically, all right? These are how we deal with branched substituents. Before we get started, I want everybody to remember that I don't make the rules. I just convey them to you, all right? So, what do I mean by branch substituents? This is something that's going to come up in, generally speaking, in longer compounds, right? Larger compounds. So let's say that I have something with this nonane parent chain, 9 carbons long. Two, 4, 6, 8, 9, yep. Okay. And then off of the middle, I have this little fork thing here. Well, if we follow our rules for nomenclature and we find our longest continuous set of carbons, the longest continuous set of carbons is that nonane. All right, so my parent is definitely the nonane. But now my substituent isn't just a straight chain group. I have this branch point in there. This whole little fork is my substituent. So how do we go about naming these substituents that have branch points in them? All right. It's actually a very similar process to what we did. Oops. Whoa. All right, again, here's my branch substituent I'm trying to name. Okay, step 1 is to find the longest continuous set of carbons. But now we're just looking in our substituent, in our branched substituent. Okay, so if we zoom in here and we're looking for our longest continuous set of carbons, I have 1, 2. All right, again, looking just in that substituent there. All right, so looking just in this portion of the molecule, I'm going to find the longest continuous set of carbons. Okay? So that's what we colored in pink here. We're going to still use those same prefixes that we used before. meth, eth, prop, but, okay? But instead of having that ane ending like we do for the parent chain, we're going to keep the YL ending, all right? So for our alkyl substituents, we keep that YL ending on that longest continuous set of carbons. So if I'm going to name this 2-carbon group right here, what would that be? There's 2 carbons, so what prefix is that? Eth, and again, we're going to keep a YL ending, so this is an ethyl. Okay. Now we have to find anything off that longest continuous set. We'll color that in green here. That's this 1-carbon group. All right. And we're also going to keep that YL ending. So this would be a methyl. Okay, we got a number again, so we're going to number that longest chain. But here there's no ambiguity in terms of which direction you number from. You're always going to start numbering where carbon 1 is the carbon that's actually attached to that parent chain. So we're going to number the longest set of carbons. Where that first carbon, C1, is the carbon bound to the parent chain. So if I'm going to go in and number here, the one that's bound to the parent chain is carbon 1. The other one would be carbon 2. All right, and now we're going to put it all together in parentheses. Assemble substituent name in parentheses. Okay, and the longest chain comes second. You don't really do it in alphabetical order. So in this case here, I'm going to put it all together. In parentheses, this would be 1-methyl ethyl. Okay, so we have this branched, we have our parent chain, right? But the thing sticking off of it now is a branched group. So how do we name that? We basically just repeat the process. Find the longest set of carbons, find whatever's sticking off of it, number that longest set of carbons, put it all together, right? With a few twists. We're going to keep a YL ending on the longest set of carbons, and when we put it all together, we're going to put it in parentheses, okay? So if I'm going to name this molecule, the parent chain was a nonane. The name of this molecule, let's see, where is it? 1, 2, 3, 4, 5, would be 5-1-methyl ethyl nonane. All right, so I'm gonna leave a few for you to do on your own. I'm just gonna do this little circle with a P in it for my parent chain. Okay, so everybody take a second and name these branched substituents here. So we have this substituent here off of my parent chain that's got this branch point. So now we got to repeat this process. We're going to find our longest continuous set of carbons, which would be 4 carbons long, right? But because now we're talking about a substituent, it's a butyl. We have this 1 carbon group sticking off of it. That would be a methyl. And now we're going to number our chain in our substituent, but we're always going to start where carbon 1 is the one that's bound to the parent chain. So 1, 2, 3, 4. So this would be in parentheses 3 methyl butyl, and then whatever the parent chain would be. Okay, same thing over here. My longest set of carbons would be these 1, 2, 3. So a propyl. I got that 1 carbon group sticking off, that methyl. Again, I'm going to start numbering, but I'm going to start at the carbon that's connected to the parent chain. So this would be in parentheses 1 methyl propyl and parentheses. All right, fun stuff. Now, to make matters worse, some of these branch groups have what are called common names, names that are widely accepted that don't fit this sort of systematic naming scheme. So for example, this one here is an isopentyl group. This one here is a sec-butyl group. All right, and there are a few of these common names that we just have to know here. So let's make a cheat sheet of all of these sort of common name branch groups that we have to know. All right, we're going to arrange them by the number of carbons that they contain. So if we have 3 carbon substituents, all right, so first of all, if it's a straight chain of 3 carbons off of my parent chain, what do we call that? Just a propyl group, right? That's a normal one. So this would be a propyl group. All right, but if we have 3 carbons and there's a little fork, this would then be an isopropyl group. All right, again, these are what we call the common names. All right. The other ones are the IUPAC systematic names. For propyl, it's just propyl. That was the normal one. Okay. But for isopropyl, that was that very, very first example that we did. This could also be called a 1-methyl ethyl group. All right, that was this very first example that we did here. So you could call this molecule 5-1-methyl ethyl nonane or 5-isopropyl nonane. And both of them are perfectly acceptable. All right, so what if we have 4 carbons? All right, so when we had this straight chain of 4 carbons, 1, 2, what do we call that? Just a butyl group. Okay, it's also the systematic name, nothing crazy there. Okay. If we have 4 carbons, but now we have a branch point at the end where we have a little fork again, this is an isobutyl group. So iso is sort of something that they give for those when you have a little fork on the end. We'll see that over and over again. Everybody take a second and give me the systematic name for this branched group here. How would you name that with the in parentheses kind of systematic naming? now you have a methyl group sticking off of the second carbon in that 3-carbon branch substituent, where 3 carbons is the longest part, so it would be 2-methyl-propyl. Okay. This one here we did before. This is what's called a sec-butyl group, SEC-butyl. And when we did this the long way, we said that this was a 1-methylpropyl. Would be the systematic name. Copying and pasting is not cooperating. Cool. And then the last one that we could have with 4 carbons where they're in a little cross is what's called a tert-butyl group. Tert-butyl. All right, so take a second and give me the systematic name of a tert-butyl group. So a tert-butyl group, right? My longest continuous set are these two here. And it's got these two 1-carbon groups sticking off. So this would be 1,1-dimethyl-ethyl. All right, and then the last one is if we have 5 carbons, and again, we have that fork at the end. So a total of 5 carbons, 1, 2, 3. This would be an isopentyl group. Or as we established before, a 3-methyl butyl. All right, so just to kind of pick out patterns here, let's see, we have isopropyl, isobutyl, isopentyl. An isopropyl has 3 carbons total and a little fork. An isobutyl has 4 carbons total and a little fork at the end. An isopentyl has 5 carbons total and a little fork at the end. Okay? Obviously, our 4-carbon group is the biggest. Let's just note that for the common names, if there's a total of 4 carbons, they all have butyl in the name, right? So that butyl is telling you kind of how many carbons there are total, and then the different patterns that we see correspond to these different prefixes. So the fork at the end is the iso. Sec, if it's on the 1, 2, second carbon, and the tert makes a little t. All right, just in terms of ways that we can try to remember this. All right. And so look, so these are kind of worst case scenario nomenclature problems. Is your exam going to be only worst case scenario nomenclature problems? No. Can you expect to have 1 or 2 worst case scenario nomenclature problems on there? Yes, right? So these branch groups, I hate them. I think they're miserable, all right? But I don't make the rules, and we just got to know them, all right? So what I could ask you, just to kind of roll it all together here, is give you a molecule like this. And say, all right, give me. Yes, it did. Wonderful. Okay, give you a molecule like this, and say, give me both the common and the systematic name of this molecule here. All right, so I got to start out the same way. I'm going to find my longest continuous set of carbons, 3, 4, 5, 6, 7, 8, 9, 10. So my parent chain here will be a decane. I'm going to number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Go the other way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to pick my blue numbering scheme, right? I want my substituent on the lowest number. Okay. If you know the common names, it's actually a little bit easier. This T-shaped thing right here is what? A tert butyl. So this would be 5 tert butyl decane. Okay. In order to figure out its systematic name, we got to kind of repeat the process, find the longest set of carbons, 1, 2. So that's an ethyl. It's got these two methyl groups on there. And we're going to number this thing where carbon 1 is what's attached to my parent chain. So this would be, in terms of just the name of my branch substituent here, this thing would be 1,1-dimethyl ethyl. All right, and when we put it in our name, we're going to put it in parentheses, right? So this would be 5,1,1-dimethyl ethyl, close parentheses, decane. Again, kind of all smushed together as one.